This lesson is about comparing two proportions, and we're going to start with confidence intervals about the difference between two proportions. So in this case, we are assuming that we are not working with any sort of matched pairs, so we're just going to have two separate samples. Okay, so I'm going to give you the formula first. My formula for a confidence interval is going to be P1 hat minus P2 hat plus or minus Z star times my standard error, which is going to be the square root of P1 hat Q1 hat over N1 plus P2 hat Q2 hat over N2. So in this case, all the ones with the ones would be from one sample, and all the ones with the twos would be from another sample. So this is going to be called a two-sample Z interval. And you'll notice that we call it that because we have a Z, we're doing a confidence interval, and we always have two samples. So the conditions are going to look semi-familiar. There's just one slight difference. My first condition is the random sample condition. My second condition is the 10% condition. You can also mention the independence condition if you want to. If they don't say a random sample, you might have to assume independence. So my third condition is the success failure. But the weird part about the success failure is I actually have to do it separately for both samples. So what will happen is I'm going to do, for my first sample, I do N1 P1 hat greater than or equal to 10. And I also want my first sample to have the N1 times Q1 hat to be greater than or equal to 10. And I also need the same thing to happen for my second sample. And we'll do an example of this in just a minute. One other thing I want to mention, which I didn't write down correctly, is that actually we have to check that both are random samples, so I should have put an S at the end of that, and the 10% condition has to be true for both of the samples that you have. Okay, so here's our first example. So we want to know if there was a change in Obama's approval rating between 2012 and 2013. So what I'm going to do is I am going to first, before I do anything else, I'm going to write out what my all of my values are, my sample statistics. So from 2012, what they tell us, my P hat is the approval rating. So my P hat, I'm going to just write it as P hat of 2012. If you want to write it as 12, that's fine, is going to be 52%. You can find your Q hat, remember, from subtracting that from 1, which gives you 48%. And you're going to find your N for 2012. That's just going to be your sample size, which was 1,500. And for 2013, my P hat of 2013 is going to be 0.46. Q hat you'll find is 0.54, and the N for that one is again 1,500. So the first thing I'm going to ask you to do is to calculate the standard error. So the standard error, remember, is the part under the square root. So I'm going to go ahead and write it out, and I just am going to end up getting the 0.46 times 0.54 over 1,500, that's the part that goes along with 2013, plus 0.52 times 0.48 over 1,500. Now, I would recommend that you work this out on your own calculator just to make sure you're not making any mistakes in it. I tend to get a lot of students that work this out and they have parenthesis issues. So please work it out on your own. You should end up getting 0.0182 or 0.018. So just double check that. And I actually asked you to interpret this value. The interpretation is probably not one of the most important things from this chapter, but it's kind of good to know. The basic idea, the interpretation of this standard error would be if we take many samples, then the difference in sample proportions would typically be about 0.018 away from the true difference. Sorry, I ran out of room here. So it's just kind of like, it's kind of telling you how far you tend to be from the actual proportion, from what would actually be the mean. So the next part of this example is going to involve constructing a confidence interval. So the first thing what we're going to do before we do our interval is we are going to write our conditions. And my first condition is about random samples. So they actually specifically tell us randomly selected US adults for both samples, which is good. We need it for both. So I'm going to say these are random samples. So that's my first thing. The second thing is that both of the samples are less than 10%. There's a lot of adults in the US, so we can definitely say that 1,500 is less than 10% of all US adults in both years. The third condition is our success failure, which is a little bit longer, unfortunately. So I have to do it for both 2012 and for 2013. So in 2012, I'm actually going to write out 2012. So my NP hat for that is going to be 1,500 times 0.52, which gives me 780. My NQ hat is going to be 1,500 times 0.48, which is 720. For 2013, my NP hat is going to be 1,500 times 0.46, and that gives me 690. And the NQ hat for that year is going to be 1,500 times 0.54, and I end up getting 810. So I'm going to say all of these are greater than or equal to 10. So the conditions tend to be a little bit longer on this because we have to check all four things. So now I'm going to do my two sample Z interval. It's a good idea to mention what you're doing. However, if you forget to mention it, as long as you write out the entire formula, including like the standard error, even with the numbers in it, then you're okay. You're sufficient with this. And actually, sometimes you'll see this. Usually I prefer to call this a two proportion Z interval. I believe in your book they mentioned it as a two sample Z interval, but I'm going to refer to it as a two proportion Z interval. Okay, so let's go ahead and work this out. The good thing for this is we already have our standard error figured out. So the first part of it, we're going to do we're going to subtract our two p hats. And if you look back up at the top, they actually want you to mention, if you look on part A, they say 2013 minus 2012. So what I'm going to do is I'm going to do my 2013 first, which is going to be 0.46, and I'm going to do that minus the 2012, which is 0.52. The reason I'm doing that is because I want to see if it increased or decreased. So if I do the 2013 first, it's going to show me if it's positive, that means it was an increase. If it's negative, that means it's going to be a decrease. From there, I get plus or minus. My Z star for 90% confidence interval is 1.645. My standard error, remember, I found it in the previous example. This is from part A. So in the end, you end up getting negative 0.06 plus or minus 0.03. So, and it's important to notice that you do get a negative. That means that his improvement level actually went down between 2012 and 2013. So my final answer for this is negative 0.09 to negative 0.03. That is my confidence interval. So let's interpret that. You'll notice that for intervals, you're generally going to have 3 steps. You have to do the conditions, you have to do your mechanics, and you have to write the interpretation. And usually they'll say use the results to construct and interpret. So especially if they say that you need to interpret it, please do that. If they don't say anything about conditions, that doesn't mean that you don't have to do them. You still need to do them. Okay, so let's go ahead with the interpretation of this. So the interpretation is going to sound semi-familiar. I'm going to say we are 90% confident and there's a few ways that you can say this next thing. I'm going to just give you the basic thing, and then I'll tell you how you can make it a little bit better, but I'll just give you the basic for now. So we are 90% confident that the interval from negative 0.09 to negative 0.03 includes the true change in proportion. Of adults who approved of Obama. And this is going to be between 2012 and 2013. So this one does end up being a little bit long. The other thing that you can also mention is that you can say that you are 90% confident that the decrease in approval rating was between 9% to 3%. As long as you mention that it was a decrease, that takes into account the negatives. It's important that you notice that, though, that we did get negatives, so that means that the approval rating did decrease. So the last part of this example, you want to know, is there convincing evidence that Obama's job approval rating has changed? Whenever you are doing an interval for any sort of 2 samples, either 2 proportions or 2 means, or even if it's a matched pair, even if it's a paired test or a paired interval, you are always going to look for 0 in the interval. So that's going to be the way that you are always going to look at this type of thing. That's going to tell you if there's a change or not. So if 0 is in the interval, then you will have, that means that you have both positive and negative values. That means that there's no evidence of changing. However, in this, our interval is very clearly below 0. So because it's very clearly below 0, that gives us strong evidence that his not only has it changed, but actually it's decreased. So I'll write that out in words. So I'm going to say, so you always have to mention two things. You have to mention that 0, whether or not 0 is in the interval, and what it actually means. So I'm going to say because 0 is not in the interval, we have evidence that his approval rating changed, and you can say changed between 2012 and 2013. I'm actually even going to write that it actually decreased. They didn't specifically ask that, but it's a good idea to mention that. So the main thing you're looking for here, though, remember, it is 0. And since we have all negative, 0 is not in the interval.